The broadcast is now starting. All attendees are in listen-only mode.
Good morning and afternoon, and welcome to On-Site Solar Storage and Gas Generation, brought to you by Generac and Xendee. Please submit all your questions through the chat, and we'll save plenty of time at the end to answer them, or we can follow up directly with you after today's event. On behalf of Generac and Xendee, I'd like to thank you all for attending, and without further ado, it's my pleasure to introduce Sydney Hodges and Hari Savedas.
Thank you, Adam. Thanks everyone for making time today. So between Generac and Xendee's and myself and Sydney, we'll talk through the role of multi-asset systems in today's commercial industrial applications. So specifically on-site solar storage and gas generators working together to solve multiple needs for customers. So thanks again for making time. Topics covered today. To start with, we'll go through a bit of an introduction and overview of the C&I market. This morning I looked at the attendee or registrant list for the webinar, and one thing that really struck out for me was the variety of audiences. And what really jumps out is the mix of folks that are, primarily pure solar or solar storage, and also a mix of folks coming from the world of generation or firm dispatchable resources. And it's interesting to see the interplay, which is exactly what we're going to talk about, and see that in the audience mix as well that have registered and shown up today. Because I think from a customer standpoint, ultimately they care less about whether it's a pure play solar firm or a generation firm or a storage firm. What they want is a way to meet multiple goals and trade off those goals to meet their needs. So we'll go through a high-level market overview. Then we'll get into why this multi-asset mix really matters and is going to be an important facet in our industry as we look to decarbonize, but do so in a cost-effective manner, and then do so in a resilient manner. After that, Sydney will go through an example commercial industrial site that we modeled in Xendee, and then discuss the results and some of the insights from that. And then lastly, we'll do some summary and Q&A. And if we don't get to all the Q&A today, I'm more than happy to reach back out to folks who've submitted questions, and between the two teams here, we can get back and answer those. So with that, just introduction. So we're all in the energy space, and if you ask, depending on what part of the energy value chain we're on, you'll see different opinions. There's the very kind of old school view of renewables just don't work. The sun doesn't shine, the wind doesn't blow all the time. Or now with the growth that storage is seeing, you'll always see the message of like, oh, we can never have enough materials around the world to build all the batteries. Let alone for C&I, we still need to do transportation first, and front of the meter storage second, and maybe residential third. That's a lot of active materials that are needed, and we'll never have enough to build enough batteries to drive decarbonization. And then you also see other forms of opinions where it's like, hey, I put in solar battery system, it worked great for me, but should work for you and everybody else. And then also things around resilience, right? Like, resilience matters, but maybe 30 minutes, maybe an hour, a couple hours. Long duration resilience doesn't go out that much. You could do load management. If it does go out, it comes back in a few hours. So you get to see this plethora of viewpoints around the energy sector. And if you're a customer sitting in the middle of that, you're getting bombarded from all different directions around what works, what doesn't work, what's good, what's bad. So that's just the reality of the world we live in. We as an original equipment manufacturer and Xendee as a solution provider, I think our view on this is how do we look at it from a customer perspective and say, if there are multiple goals to be addressed, what's the best technology mix, whether it's cost, carbon reduction, and resilience that will get us there without a lot of compromises and trade-offs. So what you'll see in this presentation is really highlighting those complexities. C&I especially is more complicated than, say, front of the meter or the residential space. But we'll go through one site. I really want to emphasize it's one site, one model, right? It's a multi-asset site. And just in that one site, the breadth of solution sets that are possible, depending on what the customer goals are, right? And you imagine that across multitude of sites, multitude of applications within CNI, and the complexity of the space really jumps out. What really is also interesting is the interplay between the assets and how the trade-off of the role of one asset versus the other is also going to change on a per site basis depending on customer goals. There's no one formula, there's no one answer that fits all. So what I really want to also emphasize is that this presentation is not about claiming that there's a silver bullet, claiming that if you do one thing and one thing only, it's going to solve all the world's problems. There is no one single asset size, mix, or solution that's going to work across all sites, many sites, every site. So this is just a flat out disclaimer, right? So this is not us trying to present just one point of view. With that, I'll turn over to Sydney to talk through Xendee.
All right, thanks, Hari. Hi, everyone. I'm Sydney. I'm Director of Customer Success at Xendee. And Xendee is a software platform that allows you to model what a distributed energy solution could look like at your site. And just like Hari was alluding to, there is no one size fits all when it comes to what the appropriate solution is for you and your site. That's really going to vary depending on kind of your utility connection, the tariff and energy rates you're on, and the structure they come in. What your personal objectives are in terms of reducing carbon or reducing costs or meeting a certain amount of resiliency. And that's where Xendee really comes in to play and is really powerful in terms of allowing you to model what your site could look like with a variety of different technologies and take advantage of optimizing for reducing costs or reducing carbon. Looking at different market participation plays you can participate in, et cetera. So it's a really powerful optimization platform that we've used in this example today to go through a case example, as Hari was saying, that'll show you kind of how you can tease out the value different assets will bring in that solution.
Great, thanks, Sydney. So looking at the CNI sector today, right? So if you're a customer sitting in the middle of it, you really have got three things you're trying to optimize for, right? Like savings, carbon reduction, resilience, and you look at all of the solution providers around the world today, and they're growing, by the day as you look at more new technologies coming to the space. It can be pretty daunting and pretty confusing in terms of who's offering what the business models are, what my ROI is. Where's my best bang for the buck? And if I do all of this, am I getting what I was promised? So in other words, it's one thing to put it on a proposal. It's another thing to actually implement it and then come back and say, I promised you, this level of resilience or this level of savings or this level of, carbon reduction. Is that actually panning out? So, on the right-hand side, you could see this is not even all the OEMs, right? This is just some, just in the space of whether it's resilience, whether it's on-site solar and storage, whether it's doing as a service models for energy or resilience, whether it's doing some sort of aggregation, demand management. Just in that, there's probably hundreds of entities doing this. And as an OEM, as a technology provider, we look at this and go, we want to be broad in terms of the suite of technologies that we offer and the capabilities that we offer, so that as a customer, we can almost play as more of an advisory role as opposed to saying you need to buy this specific widget or this specific asset that's going to meet all of your needs. And there are certain sectors that we don't even play in today, especially in the CNI side, right? Whether it's converting your thermal loads, or electrifying your thermal loads, or on the EV charging hardware side, et cetera, right? So the box is primarily where we as Generac as an OEM are playing today on the CNI side. And so why consider this asset mix, right? So which has got some renewable components, some firm dispatchable components, primarily because if you're a CNI customer, and we deal with this all the time, we've been around for almost 75 years now, supporting customers historically with resilience application and increasingly resilience and other carbon savings and energy savings solutions. You never have one goal. You have two probably major goals. Goal one, let's say, is dollar savings or carbon reduction. If you look at the last, say, 12 months or so, half the states in the United States today, we've seen about maybe 15% retail power price inflation, right? So this is not just the wholesale level, but really at the retail level where it's starting to hit people's pocketbooks. On-site solar is great. I mean, it will help as far as energy price reduction is concerned. Not only have prices gone up, but the prices are becoming more volatile, whether it's going to more tiered rate structures, whether it's seasonal or demand charges that are going up, whether it's some sort of next generation net metering type policies where you've got some real-time export prices, or in a market like ERCOT where it's primarily a price response market, there is value to assets that can take advantage of that volatility. And so you're seeing a lot of storage growth from the meter certainly, but also behind the meter. And the same thing, the combination of those assets, solar and storage, to be able to lower some site carbon footprint, right? Especially when measured against an overall grid carbon intensity at that locational point. Again, the combination can help. So that's one set of goals. Another set of goals is resilience, which is an equally important goal, and depending on C&I use case, sometimes more important in certain facilities. There, if you look at, especially in C&I, rooftop square footage, the ratio of rooftop square footage to say an average building load, there are many applications for which the amount of solar you can get on top of a rooftop is not going to be enough to offset a good portion of your building load. In some applications, you can get full offset or very large amounts that can be offset, but in some others, you just can't. So you get this wide variety of a spectrum where just saying, put one type of technology on a site is going to solve your problems. So there you run into resilience challenges. The next option is, can you pair storage with that solar and solve for resilience? Again, the question is, what is the definition of resilience, which again changes from site to site. If you've got 30 minutes of need or maybe an hour of need, yeah, pretty doable. Depending on load sizes with solar and storage. But many cases where you need those multiple hours of needs, you do run into situations where you're massively having to oversize storage where you're not going to meet those multi-hour resilience goals. So I think the big takeaway is compared to resi, where maybe there's, for single family homes, a similar type of a load profile, there's more of a role for load management. It's relatively speaking, probably more easier with the solar storage setup to be able to meet all the goals. In C&I, just given the variety of load shapes, variety of criticality of loads, variety of footprint and space available for solar or storage generator, it's a much more complicated trade-off, which is why it's not one size fits all. It truly starts with understanding the customer site of the use case. And so what we see very clearly is multi-asset systems that are becoming more common, multi-asset systems that can deliver those multiple value streams, whether it's solar for energy charge reduction, storage and or generators for demand charge reduction, because it is a dispatchable resource for certain hours of the day. Resiliency, very clearly, again, depending on the duration of resiliency. Resiliency is always defined across a spectrum. It can be in milliseconds of resiliency, or it can be multiple hours or days of resiliency, right? So in that spectrum, there's wide variety of technologies. It's not just one or the other. And then if you have those assets, that from a market participation standpoint, whether it's exports or monetizing all three assets in ancillary services markets or demand response markets, all of these have value to support the grid and in return either make money, save money for that end customer. And then lastly, distributed generation in general, it's really a bet against future utility rate escalations, right? So you can have all the wholesale prices you want. You can even have your retail price component that is somewhat reasonable, but you see many jurisdictions where just fixed costs are going up to a point where at some point you want to try and control more of your destiny with having more and more distributed generation on site. On the right side, you'll see a very live example, right? This is one of many that we see today where if not all three assets, at least two out of the three assets are becoming more common. We've seen all combinations, all three, solar storage, solar generator, depending on market. And so two or three assets, we're moving to a world where two or three assets are going to be way more common. And that brings about changes in approaches to how we talk to customers, how we as an OEM or a solution provider positions ourselves, the way the sale process works. Historically, resilience genset, is very much, almost code dominated, right? Like by code, you need to put in certain level of resilience. When you get into more of a multi-asset sale, it's a consultative sale, it's a value sell. And so it is impacting not only us, but I think the overall sector in terms of these communities coming together to make the sale. If I'm a customer sitting in the middle of it, I'm talking to a solar entity. I may be talking to a separate storage entity. Then I got to go get a generator quote from another third entity. In these communities, the more we come together and collaborate together, work together, and solve the needs jointly for the customer, I think the smoother and faster we can transition to more of a distributed, lower carbon, cheaper, resilient world. So with that, I'll turn it back to Sydney to go through an example model that was done in Xendee.
Perfect. Yeah, thanks, Hari. So just like Hari is alluding to, we went through an example of a CNI site just to be able to clearly show that value that each of these different asset types add when working in concert together. So I'll go over some of the assumptions and the analyses we ran, and then when we dive into the results, you'll really be able to see how, when they work together, these assets can deliver more value than they can individually. So the site we decided to look at is a CNI site in California in the Bay Area, so it's serviced by PG&E. It's kind of got a large, flattish weekday load from 6 a.m. to 6 p.m., so it's cutting into those peak time of use rates in the evenings. And it's got a peak of about 800 kilowatts with a total consumption of 5 gigawatt hours throughout the year, so it's a pretty sizable load. And we're assuming that the objectives that the site is solving for are reducing the costs. They're very conscious of the CO2 impacts in doing so. They're open to participating in net metering, and they want to have the option to provide that medium to long-term resiliency of multiple hours of resiliency. So when we go to the next slide, you'll be able to see kind of the approach we took in terms of the scenarios we looked at. So we looked at 5 different cases with various levels of resiliency. So we, in all of them, compared to the reference case, which is just being grid connected. So there's no resiliency, and you're subject to the tariff and the tariff structure that PG&E sets. Then we looked at what would happen if you added just solar, and then if you added solar and BESS, and if you added solar, a battery, and a generator. And in those latter 2 scenarios, we looked at whether or not you participate in net metering, so you're selling back excess energy back to the grid, or not. And then also, when you do have those dispatchable assets, whether those systems can support 8 or a full day, 8 hours or a full day outage as well. All right. And so when we looked at kind of what that looked like in Xendee in terms of the results of the optimization, in the next slide, you'll be able to see how the annual cost carbon payback compares and what those solution sizes that were recommended come out to be. So in every case, your reference case, which is that utility connected case, the black bars here on the left-hand side, it's going to cost you more and have higher carbon emissions than any solution that involves DERs. The solar is going to be able to reduce your annual costs by about $200,000 a year and reduce your emissions a little bit as well and pay back pretty quickly. However, you don't get those resiliency benefits. But then when we look at the battery and battery with generator mix for the different levels of resilience, you're not only able to beat the previous costs and carbon emissions you had in your reference case, but you're able to do so with that resiliency benefit and with generally a fairly reasonable payback, especially once you add that generator. So in order to provide the resiliency for the 24-hour resilience, you'll need to invest in a much, much larger battery. So on the right-hand side, you'll see it's an 8 megawatt hour battery, hence why it costs so much and has a very, very long payback period. However, using a generator in that mix, you're able to reduce the size of the battery you need to invest in to 1/8 of the size and still be able to meet that same resiliency and reduce your cost, reduce your carbon, have a 6-year payback. And the generator we've limited to only running for about 300 hours maximum per year. So that's how we keep the cost and the carbon down and able to and allow you to have that resiliency without additional costs beyond that. And then kind of other kind of scenarios we looked at was looking at how the storage size varies with the generator run hours. So I mentioned in these results we showed here, we were only looking at about 300 hours of running on the generator. But what we were able to test and play around with in Xendee is what happens when you limit those hours further or more, and how does that impact the size of the battery you would need and the costs associated with that. And you're able to see that even just running the generator a few hundred hours a year, you're able to significantly make an impact on the overall solution characteristics. And running that generator more, you'll save more without increasing your emission profile too much. And you'll be able to kind of bring down that payback period over time if you are able to run that generator more.
One point I would make, Xendee, on this chart is, like, again, resilience is a spectrum. So there are absolutely cases. Again, our goal here was to be showing the plethora of solutions that are available, right? If somebody said, hey, I just want 30 minutes of resilience, absolutely. I think you could do on a site like this, just do solar on a reasonably sized battery and still get away with it. But that if you've got a customer that wants those longer hours of resilience, at some point you reach an unfavorable point of no return in terms of investment costs, as we know, in storage size. And there, just opening up the possibility of having these multi-asset systems, from an investment standpoint, from a customer or a financier or developer, it opens up another whole window of possibilities. I think the important thing also, as Xendee mentioned, is like the role of the generator, right? Like increasingly we view that the role of the generator is not to sit there and be a continuous duty resource that runs all the time, right? Like the role of the generator is, okay, ideally I'd like to be there for backup only resilience, but if it means I can right size my investment thesis with solar and storage, perhaps running it for a few hundred hours when it makes the most sense, whether it's for backup or some critical economic use cases, that'll let me right size storage to make the investment pencil out, then let's consider it. And so that's why I think we looked at this from a perspective, almost like a design of experience perspective, to say, let's vary storage size, let's vary generator run hours, but let's put some limits on it, right? Like let's not model 6,000 hours a year of runtime on a gas generator. I don't think that's needed. I don't think that's probably realistic in a world where the role of solar is growing, the role of storage is growing. On the other hand, it's probably also not realistic to say, hey, I'm going to have 8 to 10 hours of resilience or long duration resilience, and I'm just going to upsize the battery. So again, the goal of the session here is to say, to kind of open up the possibilities and say, like, what other tools in the toolkit exist to find that optimal investment point.
Yeah, perfect. And as we go to the next slide, you'll be able to see kind of illustratively what Hari was alluding to in terms of how that generator can play an important role, even if it's limited in terms of the number of hours it operates. So I'll walk you through this kind of step by step. In the top left-hand side, you have kind of what a solution would look like if you only had the solar. So in this case, we're going to take advantage of that energy when we have it, when the sun's shining, and it's going to reduce our energy charges during that period. However, you can see our peak demand is nearly, or the nearly peak demand is still in those after hours when the sun's no longer shining. So we're still going to be hit by a fairly significant demand charge, and the sun's not shining during those peak hours in that duck curve in the evening when we get hit with the highest energy charges. So there's only so much benefit that a pure solar solution can bring. In these charts, you can see the black line is that building load. That's what our electrical load looks like during the weekday at this site. And each of the bars are how we're meeting that from the generation sources. So the yellow is your solar, and the blue bars are the utility purchases. So when we move to the second chart down at the bottom in the middle, this is what happens when we add a battery to our existing solar. So what you can see here is the green bars, which is those battery dispatches, are working to offset the energy charges during those on-peak hours, so to reduce those high energy charge periods, as well as to help level out our demand charges. So you can see we're using the battery a little bit in the early morning, in the afternoon to make sure that our utility purchases, those blue bars, are flattened out as low as can be, at least to justify the size of the battery investment. So it's behaving like that to lower our energy charges, reduce our demand charges a bit, and provide that little bit of kind of short to medium term resilience. The last chart on the far right is what happens when you add in that generator. So again, we have our solar and our battery reducing our demand charges, reducing our energy charges, especially during that peak period. But you'll see that the generator is coming in to help offset some of the high on peak demand charge period to enable us to get away with a smaller battery investment, but still provide that resiliency, even up to long-term resilience for the site. So hopefully this helps you kind of visualize that impact of how these assets working in concert can bring a variety of different value streams to the table.
Yeah, again, I think before we move on, this is one site, and the dispatch will look very different depending on how you size assets, right? So in the solar only case, under your demand curve, most of the supply is being filled with just solar, right? Versus in a scenario like this with storage for this one particular site, again, the optimal decision was made to charge the battery up as much with solar as possible, and then only when it's reached its full state of charge is self-consumption on site with excess solar that's starting, right? And so again, this will vary from site to site in terms of what the most optimal way to run these assets is.
All right, so the next set of analyses we did were repeating what we just went through, but allowing that the site to participate in net metering, to sell back excess energy back to the grid. So before we dive into the results, we wanted to show you kind of what the current net metering program in California, Net Metering 3.0, looks like in terms of what the price you are paid for your energy that you export is. So this was a big change that happened in April in California. Before, it used to be kind of the same structure with different time of use rates minus some bypassable charges. And instead, they've moved to kind of more of a hour by hour. That price can really vary. So you can see here that in those fall months, you'll have real peaks in terms of how much you'll get paid for exporting back to the grid. And those peaks are occurring in those evening hours, typically after the sun has gone down. So that's really incentivizing storage for different sites. So when we reran the analysis allowing net metering, you'll be able to see that we're able to capture an additional value stream and thereby lower our costs and our payback periods further from beyond our previous runs, because we're able to take advantage of selling that excess energy or charging the battery when prices are lower, or via the generator, and exporting when the export prices are higher. So you're able to play a little bit more energy arbitrage there. So again, when you add in a generator, it really allows you to downsize that battery to be kind of much more smaller and a much smaller capital outlay at the start of a project. So you go from 16 megawatt hours to 2.5, which is much more easy in terms of finding space in your facility, as well as the upfront cost you have to pay. And you're able to still take full advantage of that net metering program, and in fact, more advantage, as we'll see.
One other comment to add, this is the exact example of resilience, the role of storage, right? So in the scenario, even for an 8-hour resilience, if you look at the scenario of a solar storage and a backup generator, for an 8-hour resilience case, as a result of NEM allowing for some additional revenue capture from exports, the model didn't even pick a generator, right? So it was even able to go all the way up to 8 hours. It's a large battery, 5 megawatt hours is not a small battery for a CNI site. But it didn't need a generator to get through 8 hours of resilience. So again, this goes to show the point that resilience is all along a spectrum, and it's a function of how much you want to spend on in terms of short and long duration resilience technologies. If you're willing to spend larger amounts on a 5 megawatt hour battery, There's no absolute need to pick a MEG generator, especially in an NEM scenario like this, where you're able to monetize that battery a little bit better.
So again, we looked at kind of playing around with different variables in terms of how running the generator longer can reduce the size of the battery you need to invest in, and the impacts that that would have on your annual costs and carbon emissions and the payback for that upfront investment. So you'll see that, even running the generator 300 hours, again, you're able to get a pretty good solution, and running the generator a little bit more, but nowhere near full time, you can really capture significantly more savings.
And just to highlight the definitions, right, which we probably should have done in the first time in the graph, it's like the annual cost definition, it's not just operating costs, right? It is a combination of equipment investment costs, any ongoing maintenance costs, any running costs, any reinvestment costs, for example, accounting for battery degradation and upgrades, all of that. So same thing on generator, if it's at end of life, to add another generator, all of that gets factored into annual costs. And carbon emissions, it's any sort of on-site generation. So in this case, with the gas generator, if it runs for anything longer than any hours at all. So if it's backup, if it's only 8 hours, it'll account for that. But then it's also comparing that site generation versus the grid carbon intensity. So it was good to clarify the definitions on these.
Thanks for that. I skipped over it. All right. So then once again, we looked at what the typical dispatch would look like for a weekday at this site while allowing for net metering. So again, when you have the pure solar solution, because we didn't have enough space on our roof for enough solar to offset our peak load during the day, we actually can't take part in net metering. So it's just offsetting those midday energy charges. However, when we add in that battery, you're able to see that we're able to charge the battery from the solar and then export energy from the battery and take advantage of those high export rates in those evening hours, especially in those fall months, while also reducing our demand charges and adding in that short to medium term resilience. And then kind of most interestingly, when we add in that generator, we're able to take even fuller advantage of our battery. So instead of using our battery to offset to offset some of the load during those peak hours in the evening, we're able to run our generator and allow the battery to export all the excess solar that we had generated throughout the day. So here you'll be able to see, we're able to lower our normal energy charges as we did before, lower the demand charges, shift our usage away from those super on peak periods, as well as provide that resilience and take full advantage of that net metering program. All right, and so then when we compare kind of those last two solutions we were looking at, so the solar and battery with NEM and the solar battery and generator with NEM, when we have the same battery, the same generator solution for each of them, same solar, we're able to just capture a larger value stack. So the bar charts at the bottom here are kind of how Xendee's defining or determining where the value is coming from in this optimization. So we have a demand charge reduction component of that value. We have our energy charge reduction component. We have that export, so that's participation in that net metering program. And then we have tax rebates from the Inflation Reduction Act. And the biggest change between these two scenarios is that ability to take greater advantage of the NEM 3.3 exports. We also get a little bit more in terms of demand charge reduction and a little bit more in terms of energy charge reduction. But it's that ability to fully participate in net metering where we can really differentiate.
Yeah, and one of the comments to add that we see in real world discussions is, typically a conversation always starting, solar only, then solar storage. And then at some point it's, hey, the economics are either marginal or I can't meet a certain resilience need. So I'm going to anyway look at a backup generator or have to oversize storage. And so when we introduced this idea of like, hey, have you considered using the gen for a few hours in a year to be able to see what impact it has on the amount of storage you need, primarily for resilience. We keep noticing that opens up again that solution space. And then this was, I guess, kind of a newer market dynamic where you can take advantage of, not sacrifice, one on-bill savings opportunities with demand charge reduction, at the same time taking advantage of any export opportunities as a result of utility side incentive. How do you do that in a way that's not forcing you to double the size of one type of asset? So that's the interplay here on the top right here between the two assets. A gas generator, at the end of the day, it's a 100-year-old mature technology. So from an upfront investment standpoint, it can be lower. And again, if you're not using it, in this case, I think we modeled it roughly at around $10 or $11 a million BTU gas. You still have a reasonably favorable spark spread versus the utility. And if you're not running it that much in a year and you're able to position it in a way to maximize the value of storage, whether it's sizing wise or dispatch wise, it's a small but worthwhile price to pay or consider as part of your overall asset mix. With that, now it gets into what that site topology really looks like. Historically, when you're only doing one type of an asset, and we can say from our perspective, right, if you're only resilience focused, you have a gen, you have a transfer switch, you're sitting behind it, you're backing up certain loads, and you're done. As you go into multi-asset systems, it's less so about transfer, more about isolation and control and optimization. And so not only do the individual asset controllers start to matter, but how you knit those together start to matter even more. After you knitted them together, how you connect and control them matters even more. You can control them at the site level. You can control them in a rather set point based or threshold based kind of primitive way, or you can get into more sophisticated forecasting and economic optimization angle. And then on top of that, you've got the grid level incentives that come in, whether it's demand response plays or any sort of real-time export values that you want to capture, like with NEM. So the takeaway here is like that distributed generation topology that historically was always the complex microgrids of this world, right? I said I would never use that term in this presentation, but here we are towards the end. When you did a large airport or a large university campus, you were used to these complex ways of interconnecting systems. But I think what's most interesting is it's not the large projects anymore that are more interesting. What's most interesting is the small projects that have got 2 or 3 assets. There to see the productization of that more complex topology into smaller sites, whether it's solar battery generator with a switchgear combination, connected, controlled with a site controller on site, and having a cloud-based EMS that's doing the optimization. But to do that for smaller CNI sites as opposed to airports and universities, I think that's where we really scale. If we continue to live in the world of doing microgrids, but always talking about it from the perspective of a complex site, we never scale. We have to increasingly productize this down to smaller CNI sites. And the fact that we're starting to see more and more RFQs that are looking at these multiple assets, it gives us a lot of optimism that that's the direction that the world is going. So in summary, these are some of these points we've hit on many times during this presentation. Within CNI, it is a very complex landscape with every customer having multitude of goals, every customer having a slightly different trade-off of those goals, where you don't have a silver bullet that says if you do X and all your goals are met. This is a trade-off, and once you get into trade-offs, then you need multiple optionalities. You need to be able to understand the sensitivities of those options that are available to you. So a tool like Xendee or other tools that are available become really important as part of a sale process, which transitions from more of a widget sale to more of a consultative sale. The sites are going multi-asset, as I just mentioned. Very, very high confidence that at least 2 solar generators, solar storage. We've seen, certainly solar storage out west. We've looked at many sites in markets like Texas where, yes, you can put solar, we evaluate storage, doesn't really make sense. You might as well do a generator. And then in cases where all 3 make sense. The biggest frustration I think that if you're a customer in the space that they have is these decisions are made in silos. They have to talk to 2, 3, 4 different people, a generator OEM, solar OEM, battery OEM, many cases, a controls OEM that knits all of this together to do the site controller and optimization piece. Maybe an aggregator as far as dispatching these assets are concerned. That's 4 or 5 decision points there, right, from solution providers. If you're a C&I customer for whom energy and power is not core, you're never getting over the inertia if you continue to complicate this world, right? So that's where I think as an OEM, as a community of solution providers, what gives me hope is the diversity of audience on this call, where you've had solar folks, storage folks, generation folks, engineering firms, developers. Could we all kind of come together and create this ecosystem to be able to solve this need? Because working in silos it is not solving this need, or putting our head in the sand and saying only resilience matters, or only energy savings or carbon reduction matters. It is not solving the real world problems, which are multiple, not just one. And so this combination of assets does present an opportunity, again, to just open up the solution set and the possibilities that it brings to find that optimal point. And so from the perspective of what those assets are, certainly solar storage, and adding a flexible, limited hour gas generator really can open up possibilities to not only optimize the storage size, but also do that while hitting your resilience goals. So lastly, early and continued engagement with customers. We really strive to do that. In this market, that's probably more important than at any time before. We want to be transparent and collaborative, right? So the decisions that are made are data-driven. It is not about saying, buy my battery or buy my generator, or you need this much solar in your facility and it'll take care of all of your needs. We want to come in and say, here are your options. Each of this is a trade-off, whether it's upfront cost, whether it's emissions, whether it's sacrificing resilience, and then let's have a discussion on what works best, and then that's how the solutioning happens. And as an OEM, we want to be able to provide these enabling products and technologies in our solution set. And then lastly, no one person's going to do it alone. We have generators, we have batteries, we've got the ability to monetize those assets with the grid as part of our grid services business. We don't do solar, which is a very, very important component of this ecosystem. And there are many others who are in a different position. Maybe they don't do generators, or they only do batteries. So without an ecosystem, this thing doesn't scale. So I want to leave that as a summary. Xendee, anything from your side before we open up for Q&A?
Yeah, no, I think that's great. I think the call to have everyone kind of come together and explore a variety of different solution mixes is important. As you can see from the case we demonstrated, each of these different assets really add different values, and when they work in concert, they can add so much more. But, yeah.
Great. That's what we have. Thank you so much. Adam, I'll turn it over to you.
Well, I think we've got all the questions in, and we've answered a couple already. Hari, I had sent you one privately. I don't know if you wanted to take that one. Otherwise, thank you everyone for attending, and the presentation will be made available in 24 to 48 hours, I believe, on our webinar page on the Generac Industrial Home website. And we can certainly send a follow-up email as well that has a link to the presentation.
Yeah, I think I had one of the questions was around the definition of resilience, and as I mentioned, it is a spectrum. You can have everything from millisecond UPS-based resilience to multi-day resilience. I think with batteries and generators, you start to cover more of that spectrum. There's certainly technologies on that small end or the short end of that spectrum that we at least don't get into today, but certainly is very important as well. So, and then there was another question on why in one of the charts was a load in the early hours of the morning less than the amount of energy being pulled from the utility. Part of the reason was in the optimization, you do find, especially during off-peak hours, an incentive to charge the batteries. So even if your site loads at nights are relatively lower, if you can charge up the battery a little bit before solar comes on for you to maximize your battery charging from solar, that's what the runs were doing.
I'm seeing a few more questions come through, and if other folks have questions, please send them through and we can stay on and answer them. I think I'll read out and answer a couple that have come through. I see kind of more on the Xendee side of things. Someone asked, can Xendee model increasing fuel prices over time, and did you take that into consideration for the analysis provided here? The answer is yes, we can, and no, we didn't. In this example, we didn't look at escalating utility rates or fuel prices at all, but you can do that in Xendee if you're looking to see kind of how the solution competes long-term. Another question that came through was, what strategy did you give the battery in that example? So how does the battery know kind of when to discharge or charge or what have you? And that kind of goes back to the optimization model that Xendee's built on, and it's looking to minimize the cost of operating the full site over the full course of a year. So it's looking at every hour in the year and determining the dispatch operations of all the different technologies it has available to it to reduce that cost overall. So that's how the battery is determining kind of when to charge and discharge. Hari, there's one that came through for you in terms of, can the Generac generator participate in the California market?
Yeah, so we've got generators that do both emergency and non-emergency. In California, the emissions landscape, is obviously complicated and it varies by emissions district. But the short answer is yes, we do sell non-emergency generators into California. I would urge, if there are specific air districts for which we want to check, reach out to us, and then we'll confirm emissions numbers and specific models. But the short answer is yes, we do.
Perfect. Another question that came through is, how would having a carbon price and colder weather affect the results?
Really good question. So we didn't model carbon price, but certainly Xendee has the capability to add that. Same with the temperature derate, especially on the battery side, probably less relevant for California, but all doable within the tool. The gens themselves, the cold weather is less of a concern for the gens, and ours are rich burn gens, so it's usually very temperature tolerant even on the hot side. But both of them are doable. Again, the takeaway is like we're looking at, from a impact of fuel or even carbon price. If you're running this, say, over 1,000 hours, multiple thousands of hours, it starts to factor in a lot more. We're looking at running it on the edges, running it marginally. The role of the generator, again, I want to emphasize, is resilience plus, right? It is not continuous duty. In that scenario, you're trying to do just enough to be able to get the battery right sized and maximize the value out of that. And there, while it will have an impact, it's relatively speaking less than, say, a site that's running multiples of thousands of hours. In most cases, when we look at non-emergency generators on our side, the average run hours are 500 hours or less. So you're taking, historically in a world where it was just about one asset and resilience, a gen behind a transfer switch, you're starting to take that up by a few hundred hours, getting to a point where now you're maximizing the value of that solar and storage by having this capability with the gas gen. So.
Perfect. Another question that came through was, did the overall economics factor in long-term O&M? And yes, it did in our analysis, and Xendee's able to do that. So we were looking at the O&M costs for each of the assets individually, the fuel cost for the burn for the generator, as well as any replacement costs needed for the battery, because typically the battery, we model it's having a 10-year lifetime, so it would have been replaced, and the cost of that replacement is taken into account.
Yeah, I think in this one we looked at 15, Sydney, so I think it was a 15-year with degradation factored in, right? So it's and you accrue for that replacement in year 16, I guess, over the duration of that project. And same for the generator, right? So if you run it, irrespective of runtime for the generator, we still locked in a 15-year life for the generator. So both of the technologies are going through a replacement cycle. It's a 20-year project model. Both of them are going through a replacement cycle for which capital is getting accrued through the life of that project. So.
Another question that came through is, have you seen any hydrogen-fueled assets, either hydrogen-fueled engines or fuel cells in the C&I space?
Yeah, good question. I think depends on, let's answer each technology differently, right? Certainly on the fuel cell side, I think folks are familiar with the likes of, both Bloom that's got, PEM and I believe, so I said originally, and I believe PEM now, and then we've got a small PEM hydrogen fuel cell as well on the Generac side. It's about a 100 kilowatt unit, so a small C&I site, it's not big. And there's others in the space. There's obviously a lot of money going into hydrogen. What we see with hydrogen, especially the C&I side, is everything's cost of delivered hydrogen, right? So to displace, when we sell our fuel cells today, typically they're sold to displace diesels in construction and mobile applications. The cost to break even versus a diesel is a delivered hydrogen cost of about $7 or $8 a kilogram, which is pretty challenging, especially green hydrogen today is really, really tough. If you got front of the meter cheap hydrogen subsidized by the PTC, you may get close. Displacing natural gas gens with hydrogen in a fuel cell is really tough. I think you needed to break even of close to $2 a kilogram, which for CNI is going to be tough to get delivered. So I think the hydrogen story, again, this is one opinion, is you build it to scale, close to large front of the meter facilities. You make it and you try to consume it in industrial sites, hopefully somewhat co-located to those large wind and solar sites, as opposed to, convert it, put it in a carrier, truck it to CNI site, and then try to displace some, gas gen set on a CNI site. Probably less value. On the generator side, again, varies by OEM. There's a range. There are some OEMs that can do all the way up to 100% hydrogen today, and especially on the lean burn gas gen side, whether it's some of the Jenbacher models or Caterpillar models, there is capability. On the rich burn side for us, it's a slightly lesser number. I think we're in that 10 to 20% range. On gas gens too, with hydrogen, things also like how much fuel, how are you transporting that fuel, right? Especially if you're relying on the existing natural gas pipeline network, it's tough. We've looked at it, anything over, say, 20-25% of hydrogen transported in the existing pipeline network. We don't think it's feasible, whether it's embrittlement issues, whether it's compressor stations that need to get modified because the compressibility of the gas is different. It's a tall order. So, and the long and short of hydrogen is like, yeah, the word cost really matters.
Right. There's been a couple more questions that have come in that are a bit similar to one you've already answered, but maybe we can get a little more specific, Hari. And that's in terms of how difficult is it to get a solution that combines BESS PV and a generator permitted in California, particularly in regards to the generator from an air quality perspective, or if there are any other EPA requirements that restrict the use of generators for non-emergency scenarios in general?
No, we sell into microgrids in California pretty regularly, where you're seeing this three-way asset mix, right? So solar storage and generation for behind-the-meter microgrids. So not a new concept or a novel concept. It's happening today. We sell equipment into it today. We're not the developer, so from that perspective, like we're not handling the permitting side as an OEM. We typically support, whether it's on generation or batteries, with technical details on the products. On the generator side, emissions numbers straight from the factory for either emergency or non-emergency use. I think the complication in California is it's an air district by air district discussion, and so we always working with our local distributor on generation. At least it's a check air quality by air quality where we want to go in and understand what the limits are, what models are available, and what models are not. But these are projects that are happening today.
All right. Another one for you, Hari. Does the Generac generator directly communicate with the ESS via the Modbus TCP and work in parallel by ramping up and down, turning off when not required?
Yep, that's exactly right. I think that's the world of batteries. there's a lot of OEMs selling batteries. I don't think we're short of battery OEMs. You can walk around an RE Plus conference, and within the first 15 minutes, I think you probably run out of fingers to count the number of battery OEMs. And so you really have to ask yourself, if you've got an energy storage solution, why are you any different than the plethora of others that are around selling battery storage solutions? And so it's the interconnectivity of the and storage where you are using that generator asset to not necessarily charge up storage, because again you're using that fuel to charge storage, but more so handling those transition from, say, short duration to long duration resilience. Can you do that transition, if not truly seamless, as close to seamlessly as possible? It's that interplay, I think, where there's a lot of differentiation that is there to be had versus the community today. I think I'm speaking openly here in terms of facts, as even solar storage, I mean, we've all seen attachment rates are sub 10%. It's growing really fast. Storage is still new, for solar community in many parts of the country. And so adding that generator piece, is something that we think with our storage product differentiates us. Short answer is yes. Our storage product will communicate with the generator product. We're primarily using it for handling mode transfers, not so much for in every case, having the generator charge up the battery. I think you want to, try and limit that. You want to always try to use, solar where you can. But yes, the assets do talk to each other.
Great, and I think we've got one last one on my slide, asking if Xendee can model participation of the DERs and VPPs. And yes, you can participate in a variety of kind of different market participation programs, including acting as a virtual power plant.
Well, in closing, I'd say if there are follow-up questions, we'd be more than happy to reach back out. I think for registrants, we have contact details and happy to connect. And then if there's additional sessions, either on Xendee or anything on Generac products and technologies, happy to do one-on-one follow-ups as well where it makes sense. So I appreciate everybody's time to show up today. Hopefully it was valuable. So.
Great. Well, thanks everyone for attending, and we'll put the content online as soon as we can. Have a great rest of your day.
Thank you.
Thank you.